Hi, my name is Kepsi Richard and welcome to my YouTube channel. Today our discussion will be on finite double integration. Before the video ends, I will introduce you to what a finite and an infinite integration is. Then we'll learn how to perform one example on finite single integration. Then I will introduce you to a finite double integration. Then we'll solve some sample problems on finite double integration. This will be a very interesting engagement, so please watch the video till the end. So, we said that if we have an integration in this form, and we are asked to perform the integration of a function, let's say x exponent n, and there is no limit here, that's with respect to x, and there is no limit here, we said this integration is an infinite. I hope you get that. And when we integrate, we add the constant of integration. So remember this, we said the integration of this will just be we add 1 to the exponent and divide the function by that. So when we do that, we have to add the constant of integration. And also, we say an integration is infinite, or is finite, sorry, if there is limit of integration. Thus, we have AB of the function, maybe AXN dx. In that case, there will not be any constant of integration since we know the limit of integration. So after we integrate this, all over n plus 1, then we substitute the limit of integration, that's a and b. I hope you get that. So any place we see s, we substitute a, minus any place we see s again, we substitute b for that function, which I know you are aware of. Please check out my videos on how to perform finite integration for single integral problems. Today, before the video ends, we'll look at integration that is finite but involve double integrals. So before we go to finite double integrations, I want to refresh your mind on how to do a finite single integration for this function. So this is what we call finite integration that involves single integrals. So now how do we integrate this? Remember, this integration rule says that we add 1 to the exponent and divide the function by the result. So we integrate this 10 by 10, we get 8x exponent 4 over 4. And add 1 to 3, we get 4. Then plus 3x, we add 1 exponent 3 over 3. Then plus, this is exponent 1, so when we add 1 to the 1, we get 2 over 2. Since this is finite, we don't add the constant of integration. Rather, we substitute the limits of the integral. So now let's repolish this. 8 divided by 4 will be 2, so get 2s exponent 4. Plus this will be s exponent 3. Then plus 3s squared. It's finally substituting 2 to 3. Now what do? We substitute the 3 minus substitute the 2, which you are aware of. 2 bracket 3 exponent 4 plus 3 exponent 3 plus 3 times 3 squared. Then minus 2 bracket 2 exponent 4 plus 2 exponent 3, then plus 3 2 exponent 2. So what do we have? 3 exponent 4, that will be 81, plus 3 exponent 3, that will be 27, plus 3 exponent 2, that will be 9. Then minus 2 bracket 2 exponent 4, that's 16, plus 2 exponent 3, that will be 8, then plus 3, 2 exponent 2 is 4. So 2 times 81, that will be 162, then plus 27, 3 times 9 is also 27, then minus 2 times 16 is 32, then plus 8, then plus 12, 3 times 4, 12. So 162 plus 27 plus 27 will give us 216 minus. Then minus 32 plus 8 plus 12. 32 plus 8 is 40 plus 12, that will be 52. So 216 minus 52 will give us 162. So we can say that the integral, so that will be 164 rather. See, 6 minus 2 is 4. So we said the integral spanning from 2 to 3 of the function 8x cubed plus 3x squared plus 6x dx is actually 164. I hope you get that. Now, you know this. That will help us understand the double integration involved this. So now, we'll take some sample questions, or I'll introduce you to double integration. After that, we'll take some sample questions and see how we can deal with it. So an integration becomes a double integration and finite for that matter when it is in this form. And we perform double integration when a function is dependent on actually two variables. In that case, when we are performing integration for one variable, the other variable we had as constant, but in the integral. So that's the scenario. So when it is in this form, you see this del s will be applicable to the first integral from the right. I hope you get that. Then this will be for this. I hope you get that. So you perform one at a time. Our advice is to perform the ds first, if it is in this form, or perform the one that is here first. Then after that, you perform the second one. So now we'll take some questions and see how we can put this into practice. So let's see our first problem. They say we should evaluate the integral spanning from 2 to 4, the integral spanning from 1 to 3 of the function 9x cubed y squared dx dy. So how do we do that? So I told you that this will be for the dx, this will be for it. So for the x, then dy, this will be for it. So when I perform integration with respect to one of the function, the other function will held constant. So we can say the integral spanning from 2 to 4 and the integral spanning from 1 to 3 of 9x cubed y squared dx dy is our problem. So now I want to perform integration with respect to x. So in that case, remember how to perform integration. We add 1 to it and divide the function by the result. Immediately we do that, the one for the x will not be there. So when we perform the integration for the x, only one of the integral will remain. So I have 2 to 4 for that. So we get 9 x exponent 4 over 4. You know that's the integration rule. Then we add our constant y squared. Then now we'll be left with dy. So we can send the 9 over 4 outside. So we can say this is 9. Okay. Then we'll have our limit 1 to 3. Very, very important. Don't forget that. So we can send the 9 over 4 outside since it's constant. So we can have 9 over 4. Integral spanning from 2 to 4 of x exponent 4 y squared from 1 to 3 dy. So now I'll substitute the limit into this function. That's 3 exponent 4 minus 1 exponent 4y. So we'll have 9 over 4 integral spanning from 2 to 4 of, so let me bring my y square outside. So I will have 3 exponent 4 minus 1 exponent 4 dy. This will be equal to 9 over 4, the integral spanning from 2 to 4 of y squared. 3 exponent 4 is 81, and 1 exponent 4 is 1, so minus 1 dy. So we simplify further. We have 9 over 4 integral spanning from 2 to 4 y squared. 81 minus 1, that will be 80, then dy. Since I have 80 as constant, I can still bring it out. So I have 9 over 4 times 80 integral spanning from 2 to 4 of y squared dy. So you see that we have reduced our problem to a single integral problem. So 4 will go into 80, 20 times 9. That will be 180. So we'll have 180 integral spanning from 2 to 4. Then we integrate y squared dy. So how do we integrate this? This will be 180. When we are performing integration, we add 1. So we have y exponent 3 over 3 spanning from 2 to 4. So since this is a fraction 1/3, I can bring it out to multiply the 180. I have 180 over 3 of y cubed 2 to 4. So we substitute 4 minus substitute 2. So we have 180 over 3 bracket 4 exponent 3 minus 2 exponent 3. So 180 over 3. 4 exponent 3. That will be 64. 2 exponent 3. That will be 8. Then I have 180 over 3 of 64 minus 8. That will be 56. So 180 times 56, that will give us 10080 all over 3. So this divided by 3 is actually 3360. Then we can say the integral spanning from 2 to 4 and the integral spanning from 1 to 3 of the function 9s cubed y squared dx dy is actually equal to 3360. I hope you understand that. So let's solve our second example. They say we should evaluate the integral spanning from 0 to 1 and the integral spanning from x squared to x of x plus 3 dy dx. So remember, this will be for this. That means the dy for the first integral and dx for the second integral. See, there is no y component here. That means the y there or the integral there is 1. The integral with respect to y there will be 1. I hope you get that. So now how do we do that? So we'll say that the integral spanning from 0 to 1 of dy is y. Then we bring our x plus 3. Remember, this will span from x squared to x of dx. So we are just reducing it to a single integration problem. So we have the integral spanning from 0 to 1. Now we substitute x minus x squared. So I hope you get that. That will be x minus x squared. Then x plus 3 dx. So now we have reduced it to only x terms. So now we multiply. This times this will give us x squared. This times that will be plus 3x. This times this will be minus x cubed. And this times this will be minus 3x squared dx. So now we rearrange and group like this before we integrate. So it's integral spanning from 0 to 1 of minus x cubed being the highest term, then plus x squared minus 3x squared, then plus 3x dx. So integral spanning from 0 to 1. That will be minus x cubed. X squared minus 3x squared will be minus 2x squared plus 3x dx. Now we perform the integration. So this will be minus s exponent 4 over 4 minus 2s exponent 3 over 3 plus 3s squared over 2 spanning from 0 to 1. So we substitute 1 minus substitute 0. So we have negative 1 exponent 4 over 4 then minus 2, 1 exponent 3 over 3 plus 3 over 2, 1 exponent 2, then minus negative 0 exponent 4 over 4 minus 2 times 0 exponent 3 over 3, then plus, okay, let me clean so that I'll write it well for you to understand. So minus 0 exponent 4 over 4 minus 2, 0 exponent 3 over 3 plus 3 over 2, 0 exponent 2. All of this will be 0. So we don't have any problem with that. We'll just perform the function. We have negative 1 over 4. 1 square is 1. We have negative 1 over 4 minus 2 over 3, then plus 3 over 2. What's the LCM? The LCM here is 12. 4 going to 12, 3 times. This will be minus 3. 3 going to 12, 2 times. 4 times. Negative 2, that will be minus 8. Then 2 going to 12, 6 times. 6 times 3, that will be 18. Negative 3 minus 8, that will be negative 11. Plus 18, that will be 7 over 12. So we can say that the integral spanning from 1 to 0 and s squared to s of s plus 3 dy dx is actually 7 over 12. I hope you get that. This is very simple. We'll solve one last example on this so that you'll be abreast. So please, let's solve our last question. They say we should evaluate the integral spanning from 0 to 1 and integral spanning from 0 to 2y of xy dx dy. It's a very interesting one. Please pause the video and try solving. After that, you compare your answers with mine. So now compare your answers. You have the integral spanning from 0 to 1, integral spanning from 0 to 2y of xy dx dy. Remember, this will be for this. So that means we perform the dx first, then we go to the dy. So now how do we integrate this? The y will be head constant. So we have integral spanning from 0 to 1. Since it's constant, I'll bring it outside. How do I integrate this? I'll get x squared over 2 spanning from 0 to 2y dy. I'll substitute. So I'll have integral spanning from 0 to 1 of y. I'll substitute this minus that. Or I can bring the half out. Since this is half, I can bring it out. So I'll have half integral spanning from 0 to 1y x squared 0 2y dy. So I'll have my half integral spanning from 0 to 1y. I'll have 2y all square, 2y all square, then minus 0 square dy. So what do I have? I'll have half integral spanning from 0 to 1 y. 2y square will give me 4y square. This is already 0 dy. So when we simplify this further, I'll let the 4 multiply, then y multiply y square. So we have half times 4 integral spanning from 0 to 1 y cubed dy. So now we integrate this. Half times 4 will be 2 integral spanning from 0 to 1 of y cubed dy. So how do we integrate this? So the integral of that will be 1 over 4 or y exponent 4 over 4 spanning from 0 to 1. Since this is 1, 4, we can bring it out. So I get 2, 1 over 4 y exponent 4 spanning from 0 to 1. So this will give me half, then 1 exponent 4 minus 0 exponent 4. I hope you get that. So half times 1 exponent 4 is 1. 0 exponent 4 is 0 minus that will still be 1. So the answer will just be half. So we can say that the integral spanning from 0 to 1 and the integral spanning from 0 to 2y of xy dx dy is actually half. I hope you get it. we'll end it here today. Please remember to subscribe to my YouTube channel before you sign out. Like, comment, and share my videos. Until we meet again, my name is Tete J. Kepsi Richard.